Hello everyone, my name is Horace, and in this video we're going to be going through LeetCode number 238's product of array except self. For this problem, we're given an integer array nums, and we have to return an array answer such that answer at index I is equal to the product of all elements of nums except nums at index I. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer, and we have to write an algorithm that's running in big O of n time, and we can't use the division operator. So as always, let's go through an example so we can understand the problem more clearly. So this is the array nums that we're given as the example. So let's begin at the first element. Well, the value of the answer at the first element is going to be the product of all the following elements. So we have 2 times 3 times 4 as the value in the first element of the answer array. So 2 times 3 times 4 is simply 24. Then for the second element, we take every element in the array that is not 2. So we take 1 times 3 times 4. And that's 12. So the second element in the answer array is 12. Then for the third element, we look at every element that's not the third element. So 1 times 2 times 4, and that's 8. So the third element in the answer array is 8. Finally, for the last element, we don't look at the last element and we multiply the remaining elements, and the product in this case is 6. So the final array in this example is going to look like this. So how can we go ahead and find all the values in the answer array? So let's look at the second element. What we're doing is we're taking the product of all the elements that come from the left of the element 2, and we multiply it with the product from the elements of the right of 2. So the product on the left side of 2 is just 1, since that's the only element there, and the product on the right side of 2 is 3 times 4, so it's 12. Then if we don't include this, we can just multiply these two values, and then we get 12 as the second element in the answer array. So let's suppose we have 2 additional arrays, and we can call this the prefix, and then we can call the other one a postfix. And what these arrays are going to do is that they're going to keep the prefix products related to some element in the original nums array. So to find the elements in the prefix array, we can just take the value, and once we get to later values, we just multiply versus the previous value. So for the first one, we just simply add it to the prefix array since there's no elements before it. For the second element, it's just the prefix times the current element, so again it's just 2. Then for the third element, it's 3 times the prefix, which is going to be 6. Then for the last one, we have 4 times the prefix, which is 24. And the postfix is very similar, we just go in the opposite direction. So since there's nothing to the right, so 4 is the last element in the postfix array. Then we go backwards and we multiply the third element with the postfix. So 3 times 4 is 12. Then we have 2, and then 2 times 12 is 24. And times 1, we have 24 again. So now that we have the prefix and the postfix arrays, how can we get the final array? So the way we get the output, we can assume for the first element we have a 1, and this is just like a default value because 1 times anything will just return the number again. So for the first element we have 1, and this is going to be the prefix of the first element, and we multiply it with the postfix of the second element. So 1 times 24 is going to be 24, and that's what we got in the beginning. Then we take a look at the second element. We multiply the prefix with the postfix of the next element. So 1 times 12 is going to be 12. And then for the third element, we multiply the prefix of 1 before and the postfix of 1 after. Then we have 2 times 4, and that is 8. Finally, we just have the last element, and we do the same thing. We multiply the previous prefix value, and again, the neutral value is going to be 1. So we have 6 as the final answer. And this array is the answer that we return. Now this solution does have a time complexity of big O of n, but it also has a space complexity of big O of n, since we're using a prefix and a postfix array. Is there a way that we can reduce the space complexity? Well, we can, and we can actually get this down to big O of 1, since we know that the answer array is not counted in the final calculation, so we can just do everything in the final array. We can keep a prefix value that we can update as we move throughout the array. First, we take the prefix value and we add it to the array. Then we multiply the prefix value with the respective nums element in that index. So we have 1 times 1, but that's still 1, so we don't need to do anything. Then we move on to the second element, and since the prefix is 1, we just write 1, but now we have to multiply with the element. So now it's 2, so now the prefix becomes 2. Moving on, we write the prefix and multiply with the element, and then 2 times 3 becomes 6. So the prefix is 6, and we multiply with 4, but now we're at the end of the array, so this does not even matter. And once we get to the end of the array, we can keep a postfix value, and this is going to be initialized at 1 as well. And we do the same thing. So 1 times this value is just 1, but we update it with the nums elements. So 1 times 4 is 4. Then we multiply with the answer array. So 2 times 4 is 8. And then we update the postfix value. 4 times 3 is 12. Then 12 times 1 is 12. And 12 times 2 is 24. So the postfix value becomes 24. And finally, we multiply 1 times 24. And this is the final answer array that we needed, and this is correct. Instead of having to have 2 loops, we can do this all in 1 loop and avoid the need to calculate a prefix and postfix separately. So the time complexity for this is still big O of n, but we've managed to cut down our space complexity to big O of 1. So with that being said, we can go ahead and write the code on LeetCode. Okay, we're on LeetCode and we can start writing the solution. So we know we're going to return an array called answer. So we can define this right now and we'll initialize it with all 1s. So we'll just multiply 1 with the length of the nums array. Then we'll initialize prefix and postfix. So prefix and postfix are both going to be 1 as the default values. We can go ahead and loop over the nums array. And we only need to loop once since we're going to be handling the prefix and postfix at the same time. So we can say answer, and at the index I is just going to be the product of itself times prefix. And then we have to update the prefix So we'll multiply it with nums at the index I. And similarly, we just do the same thing for the postfix, and that's at the end. So we can just write answer, and to get the last indices, we can do -1 minus I, and this will go backwards from the array. And we do the same thing, we just multiply with postfix, and then just update postfix to be -1 minus I. Finally, we can just return the answer result, and hopefully the code is accepted. Okay, the code is accepted, and you can see that this is the optimal solution running in big O of n time and has a space complexity of big O of 1, since the output array does not count as extra space for space complexity analysis. With that being said, hopefully this video helped you and you learned something, and I'll see you soon.